Hi, today we've got the Banana Pi M2 Berry single board computer, and we will create a simple C project for it and run it instead of the operating system. The example will just blink a LED, and we will be able to communicate with the board through the UART console, which is located on those headers and is also used by the U-boat. So in order to load our project, you will have to modify the U-boat that comes together with the images of the operating systems for the micro SD card, and we will modify it to load our custom firmware into the memory. So let's get started with the project. Okay, so before you start connecting anything, make sure there's no power on both of these boards. So this is a USB UART converter, and right here we got the RX pin and the TX pin, and this is ground, and the red one is not used. So on the Banana Pi we got on top TX, middle one RX, and ground. So in this case it will be orange, yellow, brown. So something like this. And let's plug in the power. So for safety reasons, let's plug in first the single board computer, and now let's plug in the power to the converter. Like so now let's take a look at the terminal. Okay, so we are in the Microchip Studio. I got a project set up right here. So let's open it up, and let's take a look at the terminal. So let's type in the correct value for the baud rate. Let's open it up, and now let's reset the board or plug it in. So we got the output, so let's stop it. So what you are looking for is the boot command. So to see how it is, let's type in first help. Oh, and don't forget to add new line. So just enter, and right here you have a print environment command. So let's type it in, and right here we got the setup for our boot. So we are looking for this command. So right now I got it changed to load my program from the micro SD card FAT32 partition, and it loads the file named softpack.bin to this address of the external RAM, and the second instruction is to make a jump to this address. So we start our application here, but what you probably will expect from a standard Linux image would be something like something like here I got. So something like this. Okay, so to set up the boot command, you get another command. So let's again type in help, and we see a command set environment. So let's try this command. So we are changing the boot command to this value, but you also have to include those charters. Okay, and now if we run the print.env again, we can see that the boot command changed. So this is the default what you can expect from a normal Linux micro SD card image. So again, let's change it back to what we want. So set environment boot cmd, and this is the command that we want to run. Okay, so in order to save this as a permanent change, you have to type in another command. So again, you want to type in save environment. So this command, and it got saved into the micro SD card. Okay, so now let's take a look at our application. So let's restart the board and let the auto boot begin. So we got our application loaded, and we got a welcome string right here, and also the board listens for some basic command. So print kcharter, and you get a return. Sometimes this happens, so trying it again, it will be the same response. It's not the correct one, but this is because of my USB to UART converter. So just simply disconnect, reconnect. Yeah, okay, it unfroze. So let's type in K again. So now we get the correct response. So that's just my faulty USB to UART converter. Okay, so let's take a look into the main file. So at the beginning we got includes for the default headers. In this project I don't link any standard libraries. So right here I got the addresses for the first UART. So if you read this address, you get received charter from the UART, and if you put any data here, then you just send the data through the UART. Next on I got the configuration of the GPIO H. So right here is the address to set up the GPIO 20 as a output, which I'm setting bytes right here. Next on we got the state address. So right here we will be flipping the bit 20, which is responsible for the red LED. So GPIO 20. And what else I've got here are a few wait functions. So this function waits something like 500 milliseconds, something like this, just to toggle the LED so we can see it. And this waits few times less, and this is used just to make a delay for the UART, so you get the correct data sending. So this is not exactly nanoseconds, just I was too lazy enough to not check the already transmitted register for the UART, so just a basic delay. And right here we got the main, so setting up the GPIO, printing out the hello string through the print message function. And in the main loop, I check up for the K charter being received. So if it is, then I'm printing a string that it got received. And right here you just got the LED toggling. Okay, so let's go back into the basic stuff. So the startup assembler file. So right here we got the reset handler declared, and those are not used, so just only the reset handler that points to moving the stack pointer to the SRAM and going to the main function that we got in the main file right here. And the others got a wait for event, so just the core is being hung up. So by the way, right here we got 4 cores, and the U-bot uses only one. So as we start our application, we got only 1 core running, so you don't have to worry about putting the other 3 cores into sleep and so on. So just a simple example how to use the board. And right here we got in the memory map the start address of our program and the length of the memory setup. Also two simple sections for the data to load. So this is it pretty much. Okay, so now let's add something up here. So for example, at the start, let's do a few fast blinks. So let's type in a for loop int I, and for example 10 fast blinks. It's less than 10. It's incremented, and we need a blink function. So I got something like this. So just like in the main loop, we toggle the LED, and right here I got a hard-coded delay, so 2 times, and let's put this right here in. Okay, and now to the building. So in order to build this, you have to make sure that you got in the system path the toolchain reference. So for my example, system variables, and in the user profile in the path I got this referenced. So if you now would save and build it, it builds. It won't build, it won't clean up the project, because you would have to change the Linux remove into the Windows remove functions, but that's for later. Okay, so this is built. So now let's grab the micro SD card, let's plug it in. So one of the partition is not readable by the Windows, so the other one is the FAT32. So let's put it in the modified project. Okay, so now let's plug in the micro SD card and see how it looks. Okay, so let's plug in the micro SD card and let's press in reset. So it will be a very fast blink, just like this, and the board works. So, hope you find it useful in your projects, and see you in the next one.